So I'm looking to get this cube's faces, vertices, and edges. Who's got it for me? Brandon, what do you got?
It has 6 faces, 8 vertices, and 12 edges.
Excellent. So looking at number 1, what are some observations you made about the number of faces, edges, and vertices? Josiah?
All of the faces, vertices, and edges are all even.
How did I start writing that before you said it?
Because you knew what I was going to say.
How did I know you were going to say?
Because it's something everyone else says.
No, it's because I listen to everything all the time, just so you know. I hear you. Okay. What else do we notice? Yeah, Ivy? Okay, but I'm talking numbers here. Numbers in the table. What's something that just rings true? In the table, they are all less than 50. But let's think about like number relationships. Yeah. Troy. Okay, Troy, we got that. Thank you.
They're not odd.
Hi.
The number of edges divided by the number of vertices is always 1.5.
Oh, I didn't even. Edges. Okay. So I didn't even know that.
I did the edges equal 1.5.
There's always 1.5. I was thinking something like there's always the most edges. Anybody else notice? I was thinking, yeah, okay. I was thinking there's always edges are the most. Okay, so looking at number 2 here, I want to focus on this portion right here. This says to think about, are the edges always less than faces plus vertices? So let's test that out. Take 15 seconds by yourself and test that out. You're saying false? Let's test it out. 4 plus 4, I got 8. 6 plus 8 is 14. 20 plus 12 is 32. So the edges are always less than the sum of faces and vertices.
4 plus 6 is 10.
It's true.
No, faces and vertices, not faces and edges.
Faces and vertices. So it's true. Now that we know that it's true, I think there's another relationship that's kind of popping there between the sum of those and the edges. Look at between the sum of them and the edges. I wrote the sum of them.
Always 2 more.
Edges. So the edge keeps being 2 less than the sum of faces and vertices. That's kind of cool. I want you guys to write an equation using numbers and variables that says that same thing, but not in a sentence, not words. I want you to translate this to math. An equation that shows this relationship. And hearing less about this kid's iPod and more about the equation you got. All right, Sean, what's an equation we could do?
E plus 2 equals F plus V.
So if I take my edges and I add 2 to it, it would equal F plus V. That's one of the 2 I got. Kai, you got another one?
F plus V plus 2 equals E.
F plus V. So, no, if I take that number of faces and vertices and do what?
Minus 2.
Minus 2, I got you.
Oh, you wrote the wrong equation there, Kai.
I didn't.
Equals E. Edges. Cool. So we have 2 different ways to represent that.
My bad.
And what's cool now is, if I know 2 of those 3 things, I always know the 3rd thing. Because that's how solving an equation works. Or I know potential combinations that could work as well. It's pretty sweet. So checking this out, who can give me an equation for A, these blueberries? All right, Vinny.
4.99B equals 14.95.
Yes, and we can restate the situation. They cost $4.99 a pound times the number of pounds to get a total of $14.95. So who can help me with B? It's almost the same thing. Yeah, Mary?
4.99 equals C.
I don't like that they changed the variables, but it is what it is, right? It's still $4.99 a pound. We just have 2 variables now instead of 1. And C. Sean.
D plus Q equals T.
Let's do DQ, D times Q,
Disqualified.
equals T. So we're going to multiply the pounds by the price to get a total. Cool. Noah is down here working in the summer, hustling out in the streets. Okay. Oh, and May earn some money. So what's an equation that models this situation? Ivy?
275 minus 45 equals n, or n plus 45 equals 275.
Yeah, this second one's the one I used. Just because I can use the second one there to summarize the situation. Watch this. 275 is 45 more than Noah. So do you see how like that they're both true, but that second one is like the summary of the situation. Right? Is like equals 45 more is plus 45, but they're both good. Okay? E, who's got E for me? All right, Meredith.
V equals n minus 45.
V equals
N minus 45.
M minus 45. So Noah earned N dollars.
No, he earned $V. They changed the variables.
He earned V dollars, which would be like the 275. This would have to be plus 45, I believe.
No, I
N is Noah.
V is how much money Noah earned, and N is how much Maya earned.
Mr. Mac, there's
Oh,
two different ways.
it's this one. We did that one there. We just flipped the left and right. Okay.
M equals V plus 45.
Yeah, you could also do M equals V plus 45 as well. Cool. And F. Noah earned W dollars, right? So W is whatever May earned minus Y.
Yeah, I did W equals X minus Y.
Yeah. I think it'd been easier if we, or X equals W plus Y, yep. So, from the top and bottom, what are some things we notice are the same from the top and bottom? What's something, like this can be real general, Vinny. What do you notice? Variables and numbers, right? And then variables increased as we went down the row, kind of, for each different thing. We had more and more variables. What's different about the equations? They both went 1, 2, 3 variables, right? But what's different about them, Hein?
Oh, me?
Yeah.
One of them uses multiplication
Yeah.
and division, and one of them uses addition and subtraction.
Yeah, multiplication, division versus add, subtract. What else, Ivy? You got something else?
Well, just like adding Addie is like, it's for the D, E, and F, it's like how, like $45 more, so it's not like.
It's more versus per.
Yeah.
So there's some words in the situations that can tell us what we need to do, and we need to be able to interpret that to get our equation. To the price, there's tax, there's plate fees and stuff like this. So this is a pretty good representation. I think that that $120 miscellaneous charge actually might be a little higher. Depending on where you buy your car and how you do it, sometimes they roll it into your car loan so you don't even feel it, but it's there. Every car you buy, you new or used, you pay 6% sales tax on no matter what. So if you buy a $50,000 car, you're paying an extra $3,000 just in taxes. That's how taxes work. Okay? So, let's take a look at this original car price of $9,500. If I need 6% tax, what am I going to do to that?
Multiply by 1.06.
Yeah, I like to multiply by 1.06. You could also do 9,500 plus 6% of 9,500 like this. They're the same thing. And then I also need to tack on that miscellaneous charge. What operation is that? Plus 125, right? So this gives us those. Oh, sorry, 120. I was saying how it should be higher. Now, down here, what's different at the bottom there? On C. How is C different? It's given us the total price, right? These would give us the total price. On C, we're given the total price. So how do we get a total price? Now, what do we do? We're gonna show this in the equation. So what's happening to get that total price? How much is the original price? Do we know? No. No, not for C. This is different. Let's call it X since I don't know. What am I going to do to that X? 6% tax. What am I going to do after that? Add 120. So if the original price is P, I'm going to multiply by 6% and add 120. Right? What's cool about this is if you own this car dealership or you're shopping at this car dealership, which cars in the lot does this equation work for? And let's make an equation, equals total. It works for every single car there. That's kind of nice to know, like, just plug it in. 6% tax plus 120. That's there. One last thing I want to show you for number 2. This one's a kind of challenge, so that's why I want to show it to you. This says R%. So the percent changes. The only way we could do that is if we had a price, okay? Then we added R over 100 times the price. That's the only way to get a percentage to be a decimal in our equation. Well, so right here, this is the tax. The tax could be different in Indiana or Tennessee, I don't know. This would be the tax everywhere. And then I would need to add my M miscellaneous dollars. So this equation right here, now that I have two variables, this would work in any car dealership in any state. Because I can change the rate of the taxes with R. I can change P for the price of the car, and I can change the M for the miscellaneous prices. So as we add variables, it gives us more opportunities for different things. As we take away variables, it might be more streamlined, but it's only for this one thing. That's kind of what I want to point out there. All right.